Hello everyone. Good evening. Yeah, if I'm audible, so you have the message window over there. You can just type the yes. So can you hear me? Yes, beautiful, beautiful. Yes, Aditya, beautiful. Yes, good, good, good. Okay, I'll require one more thing from you, students. So there are so many students from the Pune here. So I'll just require your name and the school name from where you belong. So wherever you are now, just type your name and the school name so I can understand from where you are. Okay. So everyone, beautiful, beautiful. Kaustubh from Sinhagad. Beautiful, beautiful Kaustubh. Kaushik. Okay. Yes. Samiksha. Rihan Sinhagad. Beautiful. Yes. Rahul. I'll just discuss you a few of the details. So, do you have any idea ki which chapter we are going to conduct? Yeah, it's by default you must know ki we are conducting the introduction to trigonometry, right? So, before that, you already received one of the question paper, right? Yeah, Aditya, beautiful, beautiful. So one of the question papers. So I hope you have already solved that question paper, right? Okay, so we'll discuss that question paper and we'll tell you the solution. If you have any queries, so beautiful. So I'll definitely solve your problems and the quick revision about the trigonometry. Okay, so. So let's start first thing. So I'll start with the trigonometry. Key trigonometry is a very very simple chapter. So I'll try to cover all those things as soon as possible in a very short time. Okay. So the first thing that I'll conduct is the introduction of the trigonometric ratios. Then the second part, which is relation between the trigonometric ratios. Yes, beautiful. There is always a relation between the trigonometric ratios. They say family का relation होता है. So by default, there is a relation between those all the trigonometric ratios. Now there are some again the very tricky part, that is how to remember those ratios. So most of the time it happens कि yes कुछ आ रहा है कुछ नहीं आ रहा है. So yeah, we just lost our brain की exactly what was the ratio, right? So we'll see a simple shortcut to it. After that, the trigonometric table. So there are 0, 30, 45, some standard angles, some trigonometric ratios. So we'll try to prepare those tables. There are some examples on it. Then again, trigonometric ratios of the complementary angle that I'll explain. After that, the sum on the trigonometric ratios and the complementary angle. Right, we'll try to cover each and everything today. I already provided you the question paper. So I hope everyone has solved the question paper. So some of the students were facing some problems in the some questions. So we'll definitely discuss the whole question paper with the solution. Okay, so before that, I'll just quick revise the whole trigonometry. So now the first thing is comes in the trigonometric ratios. So it's a very basic thing. The trigonometric ratio. So we always consider the right angle triangle. Right. There is a one particular reason for the 10 standard. So we don't move for the circles or the any other figure. So trigonometric terms can be used only in a right angle triangle. So let's have a right angle triangle ABC, जो सबका favorite triangle, that is ABC. Now for the ABC, if it's a right angle triangle, so we require the hypotenuse. Now for the unknown thing, suppose if I assume this angle C as a theta, if angle C as a theta, so there must be a opposite side and there must be a, okay, this must be a adjacent side, right? So now once we have the opposite and adjacent, so the all the trigonometric ratios comes with these three parts only. One is the hypotenuse, second is the opposite side, and the third, which is the adjacent side. For the sine ratio, so you already know all these things, right? So what I'm going to tell you, it's a very shortcut things to remember all those ratio. So as sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, tan is opposite upon adjacent. So why I cover the hexagon over there? Yeah, it's very simple. So sine is exactly related to the cosec. So the relation between them is, yes, exactly reverse, right? So if sine is opposite upon hypotenuse, so cosec becomes hypotenuse upon opposite, and all those things vice versa. So next part that I'm going to conduct is the shortcut. So you must have seen so ka to, right? There's a one shortcut here, so ka to, right? So why I am using that? Yes, Rutanshu. Okay, so the shortcut that the sign is opposite upon hypotenuse, right? So this S indicates opposite sign, this O indicates the opposite, this H indicates the hypotenuse, right? So sign is equal to opposite upon hypotenuse. This is the same thing we have to remember for the next one, which is CAH, that is car. So C means cos, A means adjacent, H means hypotenuse. The same way you can say the trigonometry. So T means tangent. So S means sine, O means opposite, H means hypotenuse. So it's a very simple word. So S, C, and T, sine, cos, tan. After that, the O, H, and A. Right. So yes, beautiful, beautiful. So opposite, hypotenuse, and the adjacent, and the three basic pillars of the trigonometry, which are sine, cos, and the tan. Correct. So now next move to the another part. Okay, beautiful. So now we'll see some trigonometric ratios. So I hope everyone knows that there are two primary ratios in the trigonometry and there are four secondary ratios. So which are the primary and which are the secondary we'll discuss if you don't have any idea. So the first ratio comes in my mind, that is sine theta and the cosec theta. Sine and cosec. Why I choose sine and cosec? Because I know there's a one relation between sine and the cosec, that the sine is equal to 1 upon cosec. Correct. So sine is equal to 1 upon cosec. At the same time, when I reverse those things, so cosec theta can be written as 1 upon sine. This is the first case. Sine is exactly the reciprocal of cosec and the cosec is exactly reciprocal of sine. Now the next ratio, that is cos theta. So cos theta is 1 upon sec theta and sec theta is 1 upon cos theta. Correct. So next ratio I'll consider, that is tan. So tan is 1 upon cot and cot is 1 upon tan. Beautiful. Now you can observe those six ratios over here. So if you observe, there are some yellow and there are some green. So the greens are only sine and cos, and the yellow which are secondary. So as I told you before, so sine and the cos are the primary ratios. So sine and the cos are the primary ratios. So remaining sec, cosec, tan, and the cot, these are the four are the secondary ratios. So I'll explain how to, what is the use of the secondary and the primary. So everything, that every secondary ratio has the relation with its primary. Matlab, it's simple thing. So once we have the one family member, so he's related to the all the family things, right? So this is the same thing here. Sine and cos, we can say they are the husband and wife. So they are all related with the all their relatives, right? So husband and wife, they are all or we can say it's a mom and dad. They're all related with the all the families, right? So tan, cot, sec, and cosine. Just for our understanding, we can say sine and cos are the main ratios जिनका relation सब ratio के साथ होता है. Now, as tan and cot का relation तो primary में चाहिए, that is means sin and cos के साथ, yes, definitely they have the relation with sin and cos, that is tan theta in terms of primary. In terms of primary means in terms of sin and cos, which is sin theta upon cos theta and the cot. Exactly उसका उल्टा है, so it becomes cos theta upon sin theta. Any confusion till here? If you have any confusion, you can definitely ask me the question. So what are the confusions? I'll definitely try to cover each and everything. I can't see. Okay, yes, Rahul, just do one thing. You can just refresh the page. Maybe there's some network issue over there. So right now the internet is working properly. So you can just refresh your page. So maybe you can visit. You can see me. Okay. So now the tan is sine upon cos. Cot is cos upon sine. Now, the main part is the trigonometric table. The trigonometric table means the two things that we have to understand from here. Only one, that the trigonometric ratios, which is sine, cos, and tan, right? Sine, cos, and tan. So we call sine and cos primary because we can't represent all the other. Yes, beautiful. Yes, whenever we have the sine and cos, now you can just say for your understanding, the sine and the cos are the primary ratios. These are the two primary ratios, and cosec, sec, tan, and the cot. These are the four secondary ratios. I'll tell you what is the use of that primary and the secondary. Why I'm saying this primary and the secondary. So we'll definitely get into that. Key why I am saying those ratios are the primary and why there is a always relation between the secondary to the primary. हर एक secondary का. Okay. Yeah, everything accurately. Okay, issue that there must be a network issue, beta. So just start. You can just go in a network. So maybe you can visible me. Okay. So now sine cos tan. Okay, Krishna, you are facing the same error. So can you just check with your connection because there are so many network issues maybe happening because it's a peak time. So there are so many people are joining to the network. So it's a wireless network. So there may be some network issue. Okay, you can see but you can't hear. Okay, I'll definitely get into that beta. I'll just write to yes, there are some students who are not facing the it's working fine here. Okay, beautiful, Saket. So just try refreshing the page, so we'll definitely solve your issues. Now, what I'm okay, I was showing you the trigonometric table. So the basic thing will require is sine, cos, and the tan. These are the three pillars. I already told you these are the three pillars of the trigonometry. So we'll require sine, cos, and the tan. Fine for me as well, the Aditya. Beautiful. Okay, so now, and so the students who are facing the problem with the video, with the audio, now they can just do one thing. I'll not cover that much of part. I'll just stretch it till the 2-3 minutes, so till you join again. So just do one thing: close your browser, refresh the page, close all the softwares again, open your browser, log in, and try to launch the classroom. So I'll be here only. Okay, now the five standard angles. So always remember one thing: till the 10th standard, we have only five standard angles. So the first is 0, second 30, 45, 60, and 90. Five standard angles: 0, 30, 45, 60, and 90. So we'll try to calculate all the ratios. So now 2-3 ways to calculate the trigonometric table. So from my side, which I felt it's a very simple thing, yes, that is the five numbers. आपको सिर्फ क्या करना है? Only five numbers that you have to remember. So that's too many techniques to learn this table, but which I feel which is a very simple task. That is a five numbers by heart you have to remember. So the first number will start with the 0, right? So first number will start with the 0. I still can't hear Akansha. Okay, I'll just check it. What is the issue, beta? So Akansha can't hear. Okay, I'll just try to resolve it. Okay, so now the standard angle 0. So I'll start with the 0 here. The first is 0. After that, you have to remember one more number, that is half. And the last number that you have to remember is a 1. So you can observe here from 0 to 1. All the sign values belongs to 0 to 1 only. 0 to 1, right? So 0 to 1 means 30 is half. So by default, 45 that we have to consider is 1 upon root 2 and the 60. So now the five numbers that you have to remember, 0 and the 1, 0 to 1. So those are three number I get that between 0 to 1. Now, so sine of 30 is 1 upon 2, sine of 45 is 1 upon root 2, and the 60 is root 3 upon 2. बस यही चीज आपको याद रखनी है that 0, half, 1 upon root 2, root 3 upon 2, and the 1. These five numbers you have to remember: 1, 2, 3, 4, and the 5. These five numbers: 0, half, 1 upon root 2, root 3 upon 2, and the 1. Once again: 0, half, 1 upon root 2, root 3 upon 2, and 1. Once you know these numbers, so yes, these are the values of sine, all the angles. So sine 0, sine 30, sine 45, sine 60, and sine 90. Now, after completing the sine, you can calculate all the ratios. Suppose I got the sine 0, half, 1 upon root 2, root 3 upon 2, and the 1. So only thing that you have to do for the cos, each term say as it is, आपको just mirror करना है. So if you mirror these, the 1 comes to the first part, the last one comes to first, and the first comes to last. This becomes 1, this becomes 0. Now this half turns to here, so it becomes half here, and this root 3 upon 2 turns to here, that is root 3 upon 2. Now this is the middle term. Mirror करने के बाद we'll get the same thing, so 1 upon root 2. So I hope you understand. 1 root 3 upon 2, 1 upon root 2, 1 upon 2, and 0. This is the sequence that the first sequence of 0, half, 1 upon root 2, root 3 upon 2, and 1. Cos means usi ka ulta, right? So it becomes 1, root 3 upon 2, 1 upon root 2, 1 upon 2, and 0. Now, once we add that sine and the cos, as I told you, these are the primary ratios, right? I hope you remember sine and the cos. Now, and the tan is secondary ratio, right? The tan is secondary ratio. So tan I can write sine theta upon cos theta. Am I correct? So we already, okay, Ajay can hear. Beautiful, beautiful. So now tan is sine upon cos, right? As you know, tan is sine upon cos. मतलब यहाँ पे भी the tan will be sine upon cos. So now the simple thing that we have to do, 0 upon 1. So 0 upon 1 we get 0. That's it. Again, the sine 30, cos 30 we have. So can we calculate tan 30? Again, we'll use the same formula, sine 30 upon cos 30. So which is half upon root 3 upon 2. Now in this case, you can do the simple work that division turns to multiplication. उसके बाद reciprocal होता है. Or there is a one more shortcut to solve this kind of sum. See, we can cancel out the numerator. We can cancel out the denominator. Yes, here the denominator is 2. Here the denominator is 2. 2 gets cancelled. It becomes 1 upon root 3. right? Now the sine 45, cos 45, both the values are same. So if the numerator and the denominator is same, so what is the value that you will get? Yes, we'll get the value as a 1. Now sine 60, cos 60, we know. So can we calculate tan 60? Yes, beautiful. Again, the same logic we'll use here. Numerator upon the denominator. Numerator we cannot cancel, but denominator is again same, 2, 2. So we'll get the final answer as root 3 upon 1. So we can just write. So now, as I said, ki this becomes cancelled. So we'll get root 3 here, and the sine and the cos 1 upon 0. So 1 upon 0. Always remember one thing. There are those two simple rule about the 0 of division and multiplication, right? Whenever the numerator is 0 and the denominator is x, the numerator is 0, denominator is x ki jagah pe you can take 100, 500, whatever the number you want. If you take anything, you'll get 0 only. Whenever the numerator is 0, there will always the value becomes 0. And the second thing, x upon 0. So whenever the denominator is 0, so the answer becomes not defined. Not defined means we cannot define the answer. Whether it is 1, whether it is 1 lakh, 1 crore, 10 crore, whatever the number in the numerator, but agar denominator 0 hai, so we'll get the answer as a not defined, or in simple word you can say it's a infinity, right? So we'll get the answer as a not defined. So now I'll repeat that division once again, ki how I got that division. Suppose in this case I'll just compare with these things. Root 3 upon 2 whole divided by 1 upon 2. So this kind of calculation we generally perform a one simple step, that root 3 upon 2 divided by 1 upon 2. So now this division turns to multiplication. So what we'll do? Yes, usko will convert into the multiplication. So it's get root 3 upon 2 into 2 upon 1, then 2 gets cancelled. Then we'll get the final answer as root 3 upon 1, which is root 3. But to go by this very long procedure, so we'll have a one simple logic here. See now, this is numerator, this is denominator, this is numerator, this is denominator. So in this case, we can just do the denominator gets cancelled, right? So only denominator gets cancelled. So this numerator and this numerator, so it's become root 3 upon 1 itself. Okay, any confusion till here? Any confusion about those parts? Any kuch bhi raha ho? No confusion. Beautiful. Okay. Now, no confusion. Beautiful, beautiful. Okay, can you take a few example on it? Okay. So now it's a very simple example. But why I choose this example now, you'll get into it. Why I choose this simple example. Okay, now, okay, so value sine 30, cos 45, sorry, sine 30, tan 45, cosec 60, sec 30, cos 60, and cot 45. It's all a donkey work. That only thing that you have to perform the table, and uska baad uske aapko value substitute karne. So I already took the values over here. So once you took the values, so all the values I wrote here, and there is a denominator. So denominator बहुत बड़ा होगा. That's why I put the division sign here. उसके बाद I'll convert that division into the multiplication. All the values in the first way. This is the first step. There is no confusion in it. Now the second step, if you observe, there is a root term in the denominator. So always remember one thing. Whenever you are starting the solving, so one thing you have to remember. Whenever there is a denominator is in the term of root. Denominator में अगर root है, so उसको हमें eliminate करना है. एलिमिनेट करना है मतलब क्या, उड़ा देना है, राइट? बट दिस इज द मैथमेटिक्स. सो अपने मर्जी से तो कुछ चलता नहीं है. सो अगेन दे विल हैव अ वन सिंपल स्टेप, दैट इज द रैशनलाइजेशन, राइट? So we need to perform the rationalize. Beautiful Ishita. So we have to rationalize. So what is a rationalize? I'll tell you. Rationalize means ऐसा नंबर जिसको multiply and divide करो. मतलब एक short example if I take. Suppose there is a 2 upon 3. So इस number को if I multiply 3 upon 3, does it make any changes over here? So it becomes 6 upon 9. I can again reduce this and get the answer 2 upon 3. मतलब yes, beautiful. You have to rationalize first. So for which number, only root wala jo number hai, only that number. So in this case, these are the root numbers, right? These are the two root numbers. So sab unhi ko rationalize karna, and rationalize by which number, which is the denominator. One, there are 2-3 rules of the rationalization. As of the first example, I'll just explain the first rule. For the second example, I'll explain the second rule. So first, there is a denominator that is root 3. So root 3 को we have to rationalize. So only thing, root 3 को multiply and divide करो. As we took the 3 here, as we took the 3 here, so कुछ फर्क नहीं पड़ रहा है उसमें. The same thing, if you multiply and divide it by the root 3, we will get the same answer over here. So now this root 3 into root 3. So on the product, the denominator into denominator and the numerator into the numerator. So we'll get 2 into root 3 as a 2 root 3. Root 3 into root 3, we'll get 3. The same procedure over here. So till this step, any confusion? I hope there will be no confusion. It's a very simple step. Now the third step we come, that is, yes, beautiful. If the denominator has two terms, then yes, beautiful. That is the second step, beta. I'll definitely explain that, right? As it's the first example, so I'm just taking the single digit. On the second example, I'll take the 2, that is plus or minus the conjugate wala term. I'll definitely cover those things. Okay, so now the next part is we have to do the LCM. LCM nahi samajh rahe? No worry. Only thing ki denominator should be same, then only we can add their numerator. So addition में one एक simple rule है. Whenever there is a integers, the numerator upon denominator वाला form है, so we cannot directly add them. The third step is the LCM. LCM means the simple thing ki we cannot add the numerator and denominator until the denominator is same. So if you observe those three terms, 1, 2, and 3, there is a plus and minus sign. Okay, so 2, 1, and 3. So only one thing you have to remember: 1, 2, and 3. These are the simple numbers. ऐसा number choose करना है जो तीनों से multiplied है. That is LCM of 1, 2, and 3. Yes, it's a very simple. LCM is 6. मतलब each and every number का denominator होना चाहिए 6. अगर just in case I want 6 here, right? ये 2 की जगह पे I want 6. So by which number I need to multiply? Yes, we need to multiply it by 3. So I can say it is 3, and then it is a 6. So this 1 upon 2 I can write 3 upon 6, and this plus 1. 1 ka denominator I want 6. So definitely I need to multiply it by 6 only. So I'll get a 1. And after that, there's a 2, 3 upon 3. So 3 ko I need to multiply it by 2, which is 6. And this becomes, yes, it becomes 4 root 3. Now just observe. You can hear clearly. Same. Okay. Hello. 3 plus 6 minus 4 root 3. When it comes, yes, 3 plus 6 minus this 4 root 3. So we come to this step, and the same step will perform on this bracket as well. Okay, so now the numerator denominators, I just put at the denominator as a 6. यहाँ पे भी denominator 6, यहाँ पे भी denominator 6. I can directly add their numerator. Again, the second step comes to mind. 3 plus 6, we can take 9. But this 9 minus 4, we cannot say it's a 5. Because there is a 1, ये जो है ना, that is root 3, ये अपना दुश्मन है, which is directly comes, so we cannot add 9 minus 4, we cannot subtract 4 from 9, right? So it's a root 3 term. Now this division, when the division turns to multiplication, as we are already seen कि उसका reciprocal होता है, so this numerator becomes the denominator and the denominator becomes numerator. So any confusion till here? So यहाँ तक we got 9 minus 4 root 3 upon 6 and the 6 upon 4 root 3 plus 9. Now I guess Ishita asked me about the conjugates of the two terms, right? So we'll see now how to take the conjugate of the two terms. Now by solving, we got to the step that 9 minus 4 root 3 upon 9 plus 4 root 3. Again, there is a root in the denominator. So as I said before, okay, there is a one thing that why reciprocal? Yes, beta, why reciprocal? About just the one who asked me the question. Aditya asked why reciprocal. So on which condition you're asking me the question, Rahul? Yes, Aditya. By which question you are staying? By which steps? I'll definitely explain why reciprocal. If it's about division and multiplication, I'll definitely explain. Okay. So now if you observe there's a root in the denominator. So again, I said we don't want root in the denominator. Usko hatana hai. So now in this case, we cannot multiply by the root 3 only. Yes, if you multiply by the root 3, so just trial and error. 9 plus 4 root 3 ko, if we multiply by root 3 only. Yes, what will get? 9 root 3 plus 4 into 3. Again यहाँ पे root 3 बच गया. So that's why हमें पूरा root एक साथ हट जाना चाहिए. Right? So एक साथ हट जाना चाहिए. Okay, now the root 3 still remains. Beautiful. So now I'll tell you what is the सिंपल स्टेप हो गया है. As I said कि 9 plus 4 root 3, यहाँ पे भी root 3 बच ही रहा है. So for that we need to come with the one concept, that is the conjugate. So now I'll tell you what is the conjugate. So simple. Suppose there is a number x minus y. So x minus y का conjugate will be x plus y. Why x plus y? Because we need to perform a one simple identity, that is a square minus b square, which is a plus b and into a minus b. So right, so अगर term a plus b है so उसका conjugate will be a minus b. अगर term a minus b है so उसका conjugate will be a plus b. Right, so whenever there's a term a plus b a form में होगा तो उसका conjugate होगा a minus b. अगर term a minus b है उसका conjugate होगा a plus b. So after multiplying, yes, it's a simple identity, a plus b, a minus b. Okay, so there's the same expression with the opposite operation. Yes, beautiful, beautiful, right? So now in this case, can you just type 9 plus 4 root 3? Yes, uska to by default conjugate, this is a plus b. So a minus b will be 9 minus 4 root 3. So now in this case, the conjugate will be 9 minus 4 root 3. Now just perform this action. So numerator and denominator को same number से multiply करो. So 9 minus 4 root 3, 9 minus 4 root 3. Now, if you observe the numerator, 9 minus 4 root 3 into 9 minus 4 root 3, that is in the form a into a will get a square. So you got 9 minus 4 root 3, the whole square. After that, 9 plus 4 root 3 and 9 minus 4 root 3. I'm so sorry. Right, so it becomes a plus b and a minus b, and we know a plus b and a minus b is a square minus b square, which get 9 square as a minus, yes, it's beautiful, yes Dhwani, you can ask me the questions. So 9 square minus 4 root 3 the whole square. So why can't we skip the step of rationalization in the denominator? I mean, it can't we directly take LCM on the solve for the, okay beta. So if you have the any query, so how can we take the LCM of those numbers? In step 2, it is minus 9 in denominator. No, it's not a minus 9, it's by mistake beta, it's not a minus 9, it is only a plus. So okay, now it will be a complex then, right, you cannot directly take the LCM, because how can, it's not a perfect number, it's not a whole number, right? So whole number ke we can take the LCM. In this case 9 plus 4 root 3 ka table hi kaise banaoge to take the LCM, right? So root 3 will remain, beautiful. So that's why we are performing the rationalizing, so we won't be able to solve, right? So if you take the any LCM now, you cannot solve it, is again a correct part, or else the simple, no, sorry, it's a very advanced technique that you have. Root 3 ka value is 1.73, substitute the value and solve this. You will get you'll take more than 20 minutes to solve the same problem if you take the value 1.73, right? So instead of that, just simple perform the rationalizing technique. So rationalizing mein, if you have any approximate answer will come through, beautiful, because the 1.73 or 1.73 is not the correct answer, so which is just the approximate value of the root 3. Beautiful, so beautiful. Okay, now a square minus b square, this becomes a square minus b square. So we know a square minus b square, 9 ka square 81, and this 4 root 3 ka square, so 4 ka square is 16 into root 3 ka square is 3, so 16 3 will get 48, right? So we come to this part, 31 minus 72 root 3 plus 48. Now can anyone explain ki how this term comes? Is a minus b the whole square, right? Yes, there is again a one more algebraic identity, that a minus b the whole square is a square minus 2ab plus b square. Yes, now you got that ki a minus b the whole square is a square minus 2ab plus b square. Matlab 9 square minus 2 into 9 into 4. So 9 for the 36 to the, yes, that is 72 root 3 in the terms, plus 4 root 3 ka square, that is 48. So we'll solve this bracket in the form of a square minus 2ab plus b square. After that we'll come to the next part. So if you observe here, 81 plus 48 we can definitely add, we'll get 129, right? So we got 129 and this minus 72 root 3 as it is. Now 81 minus 48, which gets 33. Now in this case you can leave the answer till here, but always one thing, okay, when you're solving now, the answer should be in the simplest form, right? In the simplest form means जितना आप स्ट्रेच कर सकते हो, छोटा से छोटा उतना छोटा होना चाहिए. Now in this case 129, 72, 33, There may be possible ki some numbers are not divisible, but yes, here we can understand, we can take the 3 common here, right? We can take 3 common from 129, we can take 3 common from 72, we can take 33 also. So if you take 3 common, we'll get 43 minus 24 root 3 and 3 common and upon 33. Yes, 3 ones are 3 11s are. So this becomes your final answer. Board wants approx answer, but after we get the answer, only then substitute on only if given in condition. No, see better. Whenever there are the problems on the trigonometry जहाँ पे भी root 3 and root 2 वाला term है, for at least for the CBSE board they can accept this root वाला answer. Only one thing कि root वाला term should be in the numerator only. Denominator में root वाला term नहीं चाहिए. So they need to yes beta, I'll definitely, it's 8:30 to 9, will end between 8:30 to 9. I was waiting for someone to ask that question. Which question, Abhinav? Okay, so let it be. So I hope there's no doubt in this question. Yes, yes, beautiful. Nice question. Nice question. Who asked me that question? Yes, 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 yes. Who asked me that question? Sushmit, yes, beautiful. Whenever the value is mentioned, कि sin 67 है या √2 है या √3 है or it's a pi, so जो भी value given in the question that you have to substitute, but this generally not happen in the evaluate or the solve वाला term. This value are given generally in the application of the trigonometry. जहाँ the word problem ना वही पे वो answer दिया होता है. Generally solve वाले term में there is not answer is given, so you have to solve by this method only. Whenever there's an application of the trigonometry, by default you have to use the value of root 2. Suppose it's given 1.41, the root 3 is 1.73. So whatever the for how many marks? Yeah, these questions come for the 3 marks maximum. Okay, so there are so many types of questions: 3, 2 marks, 1 marks. So not for the 1 marks, 2 marks, 3 marks, or the 4 marks. So now we'll come to the next part. This is 2 tan 30 upon 1 plus tan square 30. So I'll give you a 1 minute to solve the question. I don't fall, do steps have marks? Yes, yes. The steps are always marks. So they don't check only your final answer. Even they can check your steps. That was my question. The substitute one. The substitute one. Okay, yes, yes, yes. That the substitute one ना बेटा. See, simple thing. Whenever there is a word problem ना, उस word problem में final आपको दिया होता है कि 5 is equal to 22/7 या 3.14 या suppose √2 is given 1.41, √3 is given 1.73. That time you have to substitute the value. अगर नहीं दिया है, so don't substitute the value, right? So in word problem there so is it a preferable to give the answer in the simplest form, and only if it is given in the question you can substitute the values of roots? Yes, beautiful. Yes, Abhinav, correct. So when the value is given, then only you have to substitute. So sin 60 √3 by 2. Yes, 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 beautiful, beautiful. So sin 60 is √3/2. So √3/2 means 1.73/2. So is it √3/2? Yes, it's beautiful. Sin 60 is √3/2. So as we say, the value is sin 60. Yeah, we'll definitely get to the solution. So I hope you have already solved that question. So yes, the answer is √3/2. So now if you observe here, √3/2, √3/2 comes, yes, here also it's coming, here also it's coming. So there are two options. One is sin 60, one is cos 30. Now we'll just check with the option. Yes, sin 60 is here. There's no cos 30. That means the final answer is this sin 60. Beautiful. Now the next part. Yes, the very, very important part in the trigonometry, that is the three identities. There are only three identities in the trigonometry. That one is primary and there are two with the secondary. First identity, that is sin square plus cos square is equal to 1. There are no tricks to remember this identity. You can create your own tricks or कुछ भी करके आपको ये learn करना है. So definitely I'll try to give you a simple solution, but that is not a proper way. So you have to learn this in your own technique. So sin square plus cos square is equal to 1. So Saket, please explain last sum. Okay, beta, I'll explain the last sum. Beautiful. Okay, just students, I'll just get back with the previous sum as one of the student has a doubt. Okay, now see, it says 2 tan 30 upon 1 plus tan square 30. So 2 into tan 30, the value of tan 30, just observe the value of tan 30. Yes, it is 1/√3. So now if you say 2 into 1/√3, It is hard for me to figure when the substitute into secondary or primary. Yes, beta. I'll definitely explain those wala part ki that comes in the two prove wala, right? So we are starting with the things. So I'll definitely explain each and everything. Each and everything I'll clear. Each and everything. Okay. So if you want the next session, I'll definitely arrange the next session. So don't worry about it. I'll explain each and everything. I'll solve your every issues, every problem, every query about the trigonometry. Okay. Now I was explaining this sum, right? So this is the very simple technique that first 2 into 1 upon root 3. So 2 into 1 upon root 3 I got. This is 2 upon root 3. This division signs means upon hai, so by default we'll take division. This 1 as it is, plus again tan square 30. So value of tan 30 is 1 upon root 3. Iska square है, so 1 upon root 3 का square. Now we are already seen in the last sum कि whenever there's a denominator in the root term, so उस root को हमें हटाना है. मतलब simple will rationalize with that similar term, that is root 3 and root 3. So we'll rationalize here by root 3. This 1 plus 1 upon 3. Now यहाँ पे simple cross multiplication will get 3 plus 1 upon 3, which is 4 upon 3. And here we'll get 2 root 3 and root 3 into root 3, 3. So you got 2 root 3 upon 3 divided by 4 upon 3. So उसका reciprocal मतलब 4 जाएगा denominator, 3 जाएगा numerator. So 2 root 3 upon 3 into 3 upon 4. 3 gets cancelled and 2 ones are 2 twos are. So we'll get the final answer as a root 3 upon 2. So I hope there is no issue in this question now. Yes, students. Is there any issues here? Can I go ahead? No. Beautiful. Okay. So we'll now move to the next part. That is the identity. So identity, the three identity as already explained, the sine square plus cos square is equal to 1, 0. Okay, beautiful. No, N O. Yes, nice. Got it, sir. Okay, beautiful, beta. As we have the very few times, so that's why I'm going in little bit fast. So, but definitely you can ask me the question. I'll try to revise each and everything. Now, sine square plus cos square is equal to 1. That is the first identity that you have to remember. Second, yes, second में आपको यही याद रखना है कि sec square is equal to 1 plus tan square. मतलब वो जो फॉर्म होता है एक सेकेंडरी इज इक्वल टू 1 प्लस सेकेंडरी और दूसरा भी सेम ही फॉर्म है कोसेक स्क्वायर इज इक्वल टू 1 प्लस कॉट स्क्वायर. सो 1 2 and 3, these three identity you have to remember, but don't get confused. These three identity मतलब आपको एक टर्म में ओनली दो चीजें ऑब्जर्व करनी, दैट इज साइन स्क्वायर एंड द कॉस स्क्वायर है. मतलब समवेयर वी कैन यूज दिस आइडेंटिटी. अगर एक ही क्वेश्चन में सेक स्क्वायर एंड द tan स्क्वायर है, so you can use these identity, and the cosec square and the cot square, then you can use this identity. But how and where, I'll explain, because this all the terms you can represent. Suppose in this case if I choose this sine square plus cos square is equal to 1, but can I shift this cos here? Yes, I can shift. It becomes sine square is equal to 1. This plus cos square will goes to the RHS, it becomes 1 minus cos square theta. So same thing we can apply for each and every one. So we'll get into this part key all the identities can be written in this form. So अगर मैंने ये cos इधर shift किया, so I'll get minus cos square. अगर sin shift किया, तो it become minus sin square. These are the three forms of the first identity. Now for the second, sec square and tan square. Yes, sec square is equal to 1 plus tan square. To simplify, we can just shift this tan here. So get sin sec square minus tan square is equal to 1. And the same thing, अगर tan square को लिखा, तो it becomes sec square minus 1 is equal to tan square. And same for all these three ratios. Okay, am I clear with those identities? Okay, so there are complementary angles. So before that, I'll just take the question paper in front of you. I'll just try to solve if you have any question in the question paper, right? So will there be the recording of this revision session? Yes, beautiful, beta. I will provide you the link for downloading this recording. Okay, so if it is possible, I'll definitely provide you the link of this session. Okay, so right now just observe this question paper. So I hope you already solved this question paper. So students who are facing the question problem in those questions, I'll just explain those questions over here because we have the sort of time, so we cannot explain the whole question paper here, right? So for now you can just skip this section D because I not taught the section D here, right? So okay, say question number 7 you have the problem. Okay, definitely I'll explain the question number 7. Okay, any more questions? The Krishna Sakuri wants the question number 7. So any more questions about this from the first? Yes, sir. I have solved except question number 7. Beautiful. Okay, Ishita. Yes, beautiful. I am waiting. So question number 7 we want. So okay, question number 4. If the theta is an acute angle tan theta and cot theta to find the value of tan. Okay. Question number 4 also you want solved all. Is it compulsory? Yes, Dhwani, is it compulsory? What if don't use 1.7 through 2? No, beta, it is not compulsory, but whenever it is mentioned in the question ki the value of root 3 is 1.732, so by default you have to take the value as a 1.732. अगर नहीं दिया है तो it's on your choice, लेना है तो लो, नहीं तो मत लो. Okay, so now we'll start with the solution. So I'll just take the solution of that paper, so we'll definitely get into that. So now the question number 4 has some doubt, right? So question number 4, tan theta plus cot theta we have to convert into the raised to 7 wala part, right? So it is given that here क्या दिया है, tan theta plus cot theta is equal to 2, and ये हमें प्रूफ करना है tan theta plus cot theta is equal to 2. So they have given tan theta plus cot theta is equal to 2. Okay, so now this cot theta, the only thing you have to just observe here, the third question. Okay, beautiful, I'll cover the third question. I'll just mark those question, which question you want first, third question, fourth question, and the seventh question. Okay, I'll definitely cover those all questions. So in the fourth question, if you observe this cost curve, we have to write into its reciprocal form, because somewhere we want the raised to power ना. Raised to power मतलब हमें इस simple thing कि हमें tan and cot का value हमें निकालना पड़ेगा, because raised to 7 है, so we don't have any. Please show the question paper again. Yes, Sushmit, I'll definitely show the question paper. Just go through with this solution of the question number 4. Now, the only thing we want the value of tan theta and the value of cot theta. अगर तुम्हारे पास दोनों का value है, so we can directly raise to 7 हो, raise to 10 हो, raise to 100 हो, we can do it, right? So now in this case, I want the value of tan theta, and we know cot and tan का कुछ तो relation है. Yes, tan and cot का relation is tan theta is equal to 1 upon cot theta. I can send the paper to ask any questions. Okay, I'll definitely show you the question paper. So the first, just revise this question number 4. Okay, tan is equal to, we know 1 upon cot theta. So can I replace this cot as a 1 upon tan theta? Now to solve this, we'll just cross multiply those things, because to similarize their numerator and the denominator. So to make the denominator same, we'll just cross multiply. We'll get tan into tan, that is tan square, plus 1 upon tan theta. So which becomes tan square theta plus, didn't understand how to, it become tan 20. Where it is tan 20? Okay. So tan into tan square. No, the paper won't appear. I'll explain. Just wait. Can you hear the solution of question number 4? This is a simple question from me. Just go away. Just go stay here and just observe the question number 5. Just explain in 1 minute. I'll again show you the question paper. Just wait for a minute. Okay. So tan into tan square plus 1. So tan square plus 1. ये जो denominator वाला tan है, I'll just shift over here. It becomes 2 tan theta. Now this tan square minus this plus 2 becomes here. So this become minus 2 tan theta plus 1. Now if you have any issue in this term, just observe one thing. Tan square minus 2 plus 1. मतलब somewhere we can relate this with a square minus 2ab plus b square. Right? Beautiful. So again we have to use the identity. So identities become a, just observe here. This a square minus 2, a is tan theta. We got 2 tan theta into 1 plus 1. That means this is the identity of a minus b the whole square. Right? A minus b the whole square means tan theta minus 1 the whole square is equal to 0. Anything is equal to 0, so I can just say tan theta minus 1 is equal to also 0. So tan theta minus 1 is equal to 0 means tan theta will be 1. Now we have to observe one thing कि tan theta का value 1 कब होता है? Whenever it is a color change to yellow. Okay, I'll change the color to yellow. Right. So tan of 45 is 1. So that means it's very simple कि जब tan का tan 45 होगा, then theta becomes 45, right? So tan theta is equal to 1 means theta is a 45. Now I got the value of theta, which is 45. So now I'll just substitute all the value. Tan of 45 is 1, cot of 45 is 1. 1 raised to 7, yes, we'll get 1. 1 raised to 7, we'll get 1. 1 plus 1, 11, right? 1 plus 1, 11. So we got the answer as a 2. Am I clear with the question number 4? I hope clear. Please send us the answer key. Yes, definitely. I'll send you the answer key as well. How did you get 2 tan? Okay, these 2 tan, na beta. Just one thing. I'll just take a whiteboard. Your tan plus 1 upon tan is equal to. Okay, so there was a question. Just observe. Uh, tan theta plus 1 upon. Oh, I'm so sorry. I'm so sorry. I'll just delete it. Upon tan theta is equal to 2, right? So in these steps, what we'll do, just cross multiply. So we'll get tan square theta plus 1 upon tan theta is equal to 2. Any confusion till here? No. So now the tan square plus 1 as it is, tan square theta plus 1 is equal to this tan here. So we'll get 2 tan theta. This is how we got. Yes, beautiful. Okay, now answer key is done. Okay. Now question number 3 I'll cover. After that I'll take the question number 7. So question number 3 is tan A. Yes, it's very simple. कुछ भी नहीं लगता है question number 3 में. Just observe here. So what we require, tan A given है and tan B given है. So tan A की value 1 upon root 3 है, tan B की value 1 upon sorry it's only root 3. So tan 1 upon root 3 कौन से थीटा में आता है? Yes, it is when tan is 30, theta is 30, we'll get 1 upon root 3. मतलब the A is 30. So we got the first answer and B is become 60. बस the simple thing. A की value 30 and B की value 60. Just substitute here. Sin 30 plus cos 60 plus cos 30. I only read the letter part of the question. Okay, right. And sin B, that is 60. So half into half will get 1 upon 4, root 3 upon 2, root 3 upon 2 will get root 3 into root 3 will get 3, and 2 into 2 will get 4. Now 1 upon 4 plus 3 upon 4, denominator is already same. So you can directly add the numerator will get 4 upon 4, which is 1. Okay, I hope you are clear with the question number 3. Now I'll explain the question number 7. So question number 7 says, okay, one simple trick from here will require. So question number 7. Yes, just observe one thing here. So we have the two ways over here. So we can just convert the whole question into the another form. यहाँ पे if you observe, there is a sec. Okay, but I'm not able to write it here. Not able to use the pen. Just wait here. Pen नहीं use होते. Okay. Now just observe here. So we have sec here, we have tan here, we have cos here. Agar if you see the RHS, na, what is TPT? Yes, I'll explain. So we can just turn this question into the another form. Matlab, suppose if it is a plus b is equal to, or suppose a plus b the whole square. I'll just take an example. A plus b is equal to x plus y. Can I say is a minus x is equal to y minus b? Matlab this I shift this x over here, I'll shift this y over here, right? Okay, now see, we have to prove that 1 upon sec minus tan minus 1 upon cos is equal to 1 upon cos minus 1 upon sec plus tan. मतलब what we'll do, same वाले term है, will shift to the one side. The cos वाले term will shift to the one side. So if you observe sec and tan here, sec and tan here, if I shift this sec here, do we get the plus? Yes, this term as it is, this becomes plus, so 1 upon sec plus tan, and this 1 upon cos as it is, I'll shift this minus 1 upon cos here, so we'll get 1 upon cos plus 1 upon cos, means we'll get 1 plus 1 2 upon cos. We cannot say कि cos upon cos है तो 1 upon cos it becomes 2 cos. No, the denominator will be same, so we'll get 2 upon cos x. Matlab now the LHS and the RHS are very simple here. This whole term is LHS and this whole term is your RHS. मतलब इस term को हमें ये term से represent करना है. So 1 upon sec minus tan plus 1 upon sec plus tan. Again, so whenever there's a term, denominators are different. So we'll simple do the cross multiplication, right? We'll simple do the cross multiplication. Now 1 into sec plus tan will get sec plus tan as it is. 1 into sec minus tan will get sec minus tan as it is. So दोनों का addition sec plus tan plus sec minus tan and the denominator का multiplication. So a minus b, a plus b will get a square minus b square, which was sec square minus tan square. Now just observe here, plus sec will get 2 sec, plus tan minus tan gets cancelled. So we'll get 2 sec and a identity है. Sec square minus tan square is equal to 1. How we got that? Yes, here we know that sec square theta is 1 plus tan square theta. If we shift this tan here, we'll get sec square minus tan square theta is equal to 1. So sec square minus tan square will get 1. Tan gets cancelled. Sec plus sec will get 2 sec. Yes, we already have the identity. Now 2 sec upon 1. So now 2 sec upon 1. We know the sec can be written as 1 upon cos. So we can write this sec as a 1 upon cos, means 2 upon cos. That is nothing but the RHS. We'll got this 2 upon cos x. Okay, any confusion in the question number 7? Any confusion? No, beautiful. So any more doubt in the question paper? I'll just show you the question paper once again. The question number 1 is it's pretty simple. The question 2, question 3, 4, 5, 6, 7, and 8. If you have any question, one of the last two question one. The question number 6. Okay, you'll require the question number 6. So we'll try with the cover with the question number 6. Okay. Now see beta, it's a very simple thing here. So I actually from the section D make a question number 8, means the lighthouse one or the air balloon. I'll explain the question number 6 and the lighthouse. Okay, anyone? Okay, I'll explain, don't worry about it. Okay, so LHS and the RHS, if you observe LHS, so I'll take the LHS as usual. Now जो root वाला term है, so only thing that you have to do ना कि हमें एक ही चीज पता है कि whenever there root वाला term ना कि ये root कुछ भी करके हटाना है, because we cannot perform anything in a root, because we don't have the standard identity like we don't do in geometry. Do we have to mention reason at this? Yes, every time you have to mention the reason. Every time, whatever the identity you're using, you have to always mention. So in this case, if you observe here, you can say this becomes, yes, ये tan wala identity you have to explain. For each and every step you have to mention the reason, which you understand how to solve. Yes, definitely I'll explain, don't worry about it. Okay, now I have to avoid or I have to eliminate this root wala part. So what we have to do now, ये plus है बीच में. So plus means, can I write this in a simple way? Numerator को simple separate root, denominator को separate root. I'll just split it those root. Yes, this is the same thing. Now to make the denominator same, because if you observe, अगर इसको मुझे डिनोमिनेटर का रूट हटाना है तो उसके कॉन्जुगेट से मल्टीप्लाई करना होगा, विच बिकम सेक थीटा माइनस 1, और जो कॉन्जुगेट मुझे ऑलरेडी प्रेजेंट है, सो वो मल्टीप्लाई करने की जरूरत नहीं. व्हाट आई विल डू ना, सिंपल क्रॉस मल्टीप्लिकेशन. दिस सेक थीटा माइनस 1 इंटू सेक थीटा माइनस 1, दोनों रूट में, सो रूट इंटू रूट विल गेट विदाउट रूट. मतलब सपोज रूट 2 इंटू रूट 2 विल गेट 2. So this root into this root will get only that number, so we'll got sec theta minus 1. यहाँ पे भी same thing, it becomes sec theta plus 1. Now this is a plus b, a minus b. So in this term it's a plus b, a minus b. So in denominator becomes root of sec square theta minus 1. So जैसे term में होता है, we can write a plus b into a minus b in the term. So we'll get a, this question is in the form of outside, which okay, I'll solve a square minus b square in the root. So the same step I took here, sec square theta minus 1 in the root. Now sec square theta minus 1 is the standard identity that sec square theta minus 1 is equal to tan square theta. So I put here the tan square, 5 tan theta minus 4 is equal to 0. Then find the value of 5 tan theta divided by, okay, this is the question you are, but there is a denominator won't be the root sign too, because we are multiplying root into root, right? Beautiful, there is a no root sign. So but in this case na beta, they are not a same number, right? If there is a root 2 into root 2, then only it becomes 2. But there are two different terms. If you observe the sec theta plus 1 in the root and sec theta minus 1 in the root, दिखने में same दिख रहा है, but there is a addition वाला फर्क है, right? So sec theta plus 1 and sec theta minus 1. And I guess Samiksha, you asked me the question, right? So you ask me the question, I'll definitely get that question and I'll solve this question in the next session, because I have very less time left, because I will already extended the session, so I cannot solve this one, right? So Samiksha, I'll note your question. I'll definitely solve your question on the next session. I'll just copy that question. Just wait for a second. Okay. So now after that, if you observe this sec theta plus 1, sec theta minus 1, so I'll use this wala identity. So a square minus b square, so sec square theta minus 1, so 2 sec theta, ye jo hai minus 1 plus 1 gets cancelled, this sec theta plus sec theta becomes 2 sec theta, and the denominator mein root of tan square theta. So root of tan square theta matlab uska square root liya, to it becomes tan theta only. Yes, I got tan theta. Can you repeat this, sir? Okay, what you want to repeat the same whole step? Okay, just what I'll do, simple root numerator, root denominator. There'll be any. Yes, yes, definitely. We'll arrange more session. We'll arrange a more session as soon as possible, Saket. Yeah, you're already on a group. So whatever your demand now, you can just put you can just ping on that group. So which chapter, what kind of things you require, I'll definitely combine all the thing. I will take the session on that particular thing. Okay, so don't worry about it. Uh, now the LHS, if you observe. Okay, yes. How many you are chatting? I'm getting disturbed. Just wait for a minute, beta. Okay, AP, just wait for a minute. Just let me complete those things. Okay, I'm getting confused. There are a lot of messages coming. Okay, so sec theta minus 1. I'll just take the numerator separate, denominator separate, numerator separate, denominator separate. Now, the simple cross multiplication. Root into root wala term, root हट जाएगा. This root into this root, ये भी root हट जाएगा. And the denominator में it's a plus b, a minus b in the root. So it becomes a square minus b square. So sec square theta minus 1. And this is the standard identity that we can write tan square theta. Right, so 2 sec theta upon root of tan square theta. So root of tan square theta I'll get tan theta only. So I got tan theta here. Now we have already seen कि हर एक सेकेंडरी का प्राइमरी के साथ कुछ ना कुछ रिलेशन होता है, right? So everywhere we have the relation with the primary. So sec theta का primary relation is 1 upon cos, and whole divided by tan is sine upon cos. As I told you, you can directly cancel out if you are good in the mathematics and the solving. So cos gets cancelled, will become 2 upon sine. So we got the answer 2 upon sine, and we know 1 upon sine is cosec theta. So that is what we want and the RHS. So any confusion in question number 6? So I hope you have covered all the questions. Didn't understand how root got removed in the second step. Okay, anonymous, you asked me the question how. Yes, anonymous. So do you have any confusion in the question number 6, question number 7? Any question till here? No. Beautiful. Now, students, one more thing I'll require. So just for my understanding. So yeah, there are some students from the Aound. There are some students from the Kondwa. There are some students from the City International Wanori. City International Aound. So let me just tell me your school. You're from which school? Wanori CIS, Aoun CIS, or MT Kondwa branch, MT, whatever is there. So just tell me, yes, you are from Sinhagad Road, beautiful. Just give me a message. Lok Seva School, beautiful, beautiful. Just give me a feedback. Give me a, yes, Aoun CIS Krishna. Okay, good. Okay, so Sinhagad Road branch, beautiful, beautiful. The Orchid School, Sinhagad City School, beautiful. Now, students, any confusion in the whole today's session? Any confusion? I'll share all the notes of the today's lecture. So you want the question paper, you want the solution, you want the whole this trigonometry thing. So I'll share all those things. So don't worry about it. Everything I'll share. Okay, no confusion. Beautiful. So now this time to leave, and it's a very nice lecture with you. I'll definitely arrange the next session as soon as possible. Just you'll just wait for your demands. So whatever the demands you have now, I'll definitely clear. Good night. Yes, yes, thank you. Thank you so much, Abhinav. Thank you so much, Saket, Ishita. Thank you. Thank you so much. Yeah, good night, sweet dream, Rahul. Everyone, good night. Good night. Yes, thank you. Tata. 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 Good night. Yeah. Bye.